My name is Carsten Bockholt. I'm Managing Director of the company Helmholz, and today I would like to give you some insights about the security regulations, actual security regulations, and just one solution for one typical problem to simply secure your machines, your network of your machines. Okay, some facts and figures about the company in the beginning. I'm not sure if everybody knows us and the company before. The company Helmholz started with PLC programming. So Mr. Helmholz started PLC programming and programming machinery. So he knew what the typical problems are of machine builders. And but we changed a couple of years after starting with PLC programming and programming machines already to develop components for in the past it was Simatic S5 and later S7-300. So we have a long history with PLC components. And we are located near Erlangen in Bavaria, Germany. You see in the picture our headquarters. We have 90 employees and 75 of them are on site, so in this building. And we do almost everything in-house. So we do the development, hardware and software development. We have the purchasing, we have the marketing, we have the sales, we have the hotline, and also the production. And the production is doing the assembly of the products and testing of the products. 100% of all products are produced and tested in-house here in Großen Seebach near Erlangen. And we have over 36 years of experience in automation. So we know what the typical problems of machine builders and end customers are. And we sold 50 million products since, I think, since 2000. We have no older statistics about the sold products because in 2000 we changed to a new software for sales. And we have about 1,500 customers worldwide. Okay, just a small overview about our line card here. Let's start on the left with let's say more easy products or low level products. We start with the connectors for Ethernet or Profinet especially. The next pillar we have monitoring devices to monitor the cables or reading Ethernet data from cables from the Ethernet communication. On the next level we have the unmanaged switches in different sizes and different designs. On the next, we have the Profinet, the managed switches, especially for Profinet. And we have an own I/O system for connecting sensors to the machine. And here on the next level, this is a part we also will talk today, are the gateways. And on the highest level, we have the remote maintenance and the firewalls. And this is a part of our product range, especially focused on communication. So let's start. Why is security in the industry so important today or now? We will talk about security in the whole webinar today. And why do we have it? I think you are interested in this webinar because you already know you have to do something. But we have to take a look back to see the history. And what is the most important point we have today? Ethernet everywhere. So we are no longer an island. So the machine is not an island with closed communication like Profibus, no connections to outside. There's only a panel or some buttons and lights to see what the machine is doing. But nowadays, or let's say since the last 10 years, we started to connect our machines to Ethernet, or we have Ethernet inside, like Ethernet IP, Profinet, Modbus TCP, everything. So we have this Ethernet communication. So this is the first reason why we have to think about security. We have communication from the sensor to the cloud. So we not only connect the machine to the high level company network, we also connect the sensor in the machine to the cloud. So we have this over all the areas, over all the network parts into the cloud, we have communication. We have an increasing digital complexity. So we are not handling one or two protocols, we're handling many protocols, starting with the Profinet, Ethernet IP stuff, up to web and FTP and OPC-UA, Modbus TCP, MQTT, and name it. It's a long list of different protocols which are used on the same Ethernet line, and sometimes you do not even know what communication is going on your Ethernet. So this is also a big problem. And we also have the regulation of data protection. So this is not only a part of protecting our asset, it's also protecting our data. And this is already in regulation, so we also have to consider this. Yeah. And all this Ethernet everywhere, communication from sensor to the cloud, and connecting our machines to the network, to the internet, brings up new people on this game. And yeah, this is bad guys coming up. And in the past, the bad guys are mainly focused on company networks or focused on private people, PCs, and but the hackers are focusing more and more also on the OT networks. Yeah, we have different types of attackers. Sometimes they are mixed, but we have, I think, three main types. The first is the criminal attackers. For example, with ransomware, they want to have money. They block or they crypt your PCs. You cannot work anymore, and they say, okay, please pay your money, and then you can use your IT. We have the industrial attackers. That's a part of information gathering and let's say getting information from industry and use it somewhere else. And we have the political attackers. So it's also information gathering, but sometimes it's sabotage. And so we have these three types of hackers, but sometimes they are mixing up in a way. And so yeah, and this is what we have. We think we have our IT, we have our company already with some firewalls. We have the IT guys; they know what security is, and we say, okay, should be okay having a machine with communication to the cloud, but on the viewpoint of a hacker, they know where you have bad technology or not secure technology. They find it and they will attack it in the future. Yeah, and for all this leads also to legal requirements. So it's not only that we want to be secure in our asset, in our machine, and because we do want to use our machine all the year, all day, 24/7. There's also from the legal side many new requirements coming up, and this what will I show you on the next slide. So what do we have on security regulations and directive and standards? And the first thing, which is I think everywhere in mind at the moment, because it was started in December last year. It's the Cyber Resilience Act. And this has come into force in December last year. And the Cyber Resilience Act focuses on products, not on machines, on products. So parts like Helmholtz is producing, parts like Siemens is producing as a PLC or a panel or some products like this. And this Cyber Resilience Act is focusing on many products, also your mobile phone or your intelligent television or your heating system, which is connected to the cloud in your private home. And the Cyber Resilience Act is focusing to all these digital products which are able to communicate. And the special point is all the industrial products are also inside the scope of the Cyber Resilience Act. Yeah, and the implementation of the regulation or effectiveness is in December 2027. So we have nearly 3 years to get it running. And yeah, we as company Helmholtz already doing this. And yeah, we have to get all our products in one or another way secure. And the very important part of this Cyber Resilience Act is that the security conformity declaration will be in the CE declaration. So together with the EMC and the REACH and ROHS stuff you have to declare in your CE declaration, you also have to declare that the product you are selling from December 2027 on is secure. And this is a really important topic, and all the manufacturers in here in Europe are working on this to get all the products, let's say, as secure as possible. The next thing, it's interesting for the machine builders and the end customers and asset owners is the new machinery regulation. So there was an old machinery directive, and this was changed to a machinery regulation. So it's effective in total Europe without any local law. And this is focusing on parts of machines or total machines. And it's focused from the point of view or from the writing of the machinery regulation, it's focused on product safety. So that the machine does not harm people or destroy assets or whatever in this context. And a big part coming in the new regulation is you cannot get any safety if you are not secure, because you should have a safety product like a yellow part, the yellow boxes with safety functions or like this. But if this product can be somehow attacked by a hacker, it cannot be safe. It cannot be a safety product anymore if it's not compromising security. And this one will be effective in January 2027. So it's a little bit earlier than the Cyber Resilience Act. And then we will talk about the IEC 62443, which is a standard we can use for our products at Helmholtz or for machine security, practical implementation for industrial products. So the IEC 62443, and I will explain it a little bit more in the next slides, is for the practical implementation, because the Cyber Resilience Act and the machinery regulation are stating in as a law that you have to do some things, but it's not in the law how to do it. So, and how to do it in a practical way for a product, for a machine, or for a factory is stated in the IEC 62443, especially for industrial machines. And we have one more directive already effective, but not a local law in Germany here, but it's already effective in Europe. It's a NIS2 directive, and the NIS2 directive is a different approach on all the security stuff. It applies to companies and company IT. So this is not a product or a machine. This one is focused for the company like us. We are producing products. We have to secure our IT, or for the machine builders, they have to secure their company IT, and especially for the factories or the companies which are having the machines inside the factory, they also have to secure their IT. And this is, let's say, an update of the NIS directive, which is already effective, and the NIS2 is a newer version, which is addressing new attacks or new ways to regulate the security in companies. So this is focused on the company, not on the product or machine. Okay, so we will focus on these Cyber Resilience Act. We will focus on the machine directly, and especially I will focus on the 62443 as an example. I explain, but you should know that there are many more standards on the market which are focusing security already now, or effective, or new standards coming up. And one is the Radio Equipment Directive, and this one is focused on products which are using Wi-Fi, Bluetooth, LTE, 4G, 5G communication. So everything which is wireless is covered by the radio equipment directive, and this was updated with some new articles, and there's also a new normative coming up, and this was added. For example, the article 3.3 added security to this part. In the past, it was more focused on how much energy on the antenna and EMC and stuff like this. This was the focus of the radio equipment directive, and nowadays it was updated to topic security. So it's also important if you have some wireless products, you're selling wireless products. And then we have some other guidelines, especially for manufacturer cybersecurity, but these contents are mostly integrated in the newer standards. We have automotive communication, which is really special, UNR 155 and 156. So if you are producing parts which are built in automotive, you will know this, and this is also focused on security in automotive communication. Medical devices already established IEC standard, and yeah, we have this well-known 27001 IT security standard, which is also existing and effective, and you can use this, for example, to fulfill the NIS2. Yeah, functional safety, you should know it. It's also stating the security. And if we take a look over the big lake between us and the United States, you will see that the United States is also very, doing many measures to secure their machines, their products, and their factories. So they have, for example, an executive order, which is focused on nation cybersecurity, and they have the Cyber Trust Mark Act, which is not for automation but for all other products. And they also have this common criteria, which is more focused on IT components. So there is many stuff going on in the United States. The good thing is, as far as I know, they accept the 62443 normative if you develop your products by 62443 or by these normatives, it's also accepted in the United States. Okay, so let's dive into the normative structure of the 62443, which will be, on my opinion, the most important normative to fulfill all these legal requirements of Cyber Resilience Act and the Machinery Directive. The IEC 62443 is structured in 4 chapters. There are more chapters for other things, but this is the main 4 chapters we have to know. The left one, the 1 is the general, glossary and metrics and stuff like this. And then we have the 2, the 3, and the 4, the chapter 2, 3, and 4 here. And we will begin at the end, at the chapter 4, because this one is for product manufacturers. So if you take the normative and read the chapter 4.1 and the 4.2, you will find explanation how a product can be developed in a secure way and maintained in a secure way, and also which technical requirements have to be implemented in a product. So this red area here is for Helmholtz, is for us, to how to make products secure and how to develop them in a secure way. It's not only development, it's also maintaining. So we know if I have a product like a security product and it's finished and it's always working in the same way, it's tested, it's working. But in the security, we know that everything is changing. You can have a secure product and next day they find some vulnerability inside the software you're already using, like Linux. And then your product is not secure anymore and you have to do something. So the process is more important than the final firmware you have in the moment. Okay, so let's get one pillar to the left, the chapter 3, and this one is for machine builder and solution providers. So system is a name. So these chapters explain how to do a risk assessment and system design of a machine, which security requirements come for a machine, not a product, a machine. So a complex system with network, with switches, with communication between different products. And this is what you have to read and to understand and to use if you are a machine builder and you want to sell products or machine parts in the future, also on the machinery directive. And on the highest level here, chapter 2, this is focusing on the end customer, on the operator, on the asset owner. And this is the one who is using the machine, who is maintaining the machine, who is having many machines in his company and connecting all these machines in the bigger network and have the communication over his company network, enterprise level, internet, and so on. So they also have to do something to secure the running machines and to maintain the machines. So this is the logic behind the 62443. And I will give you some concepts so you understand what's behind all this standard. If you read it, you read some topics, but you have to understand the concept behind it. And then the first and most important concept, which is in the total 62443, is the defense in depth. Defense in depth is the logic behind it. And you can take it, we had in the first slide, you had this castle or this fortress picture. And if you go back to the medieval times and you are a king and you have a big castle or a fortress, and they are also built in the same way. The first thing, you remove all the trees in front of your castle because you want to see if some attackers are coming. Then you have some small mountains or some small areas, and then you have a moat or a trench where you have water inside, so nobody can walk to your castle. And then you have the wall, and you have the bridge. You can draw the drawbridge, and you have some guards on the wall, on the towers, and they check if you are allowed to come into the castle. And if you are inside the castle, you are trusted a little bit more, but you are not meeting the king because the king is living inside the castle, inside an extra building, which is always have extra guards. And you have to pass the first guards, you have to pass the second guards. And then if you are inside, then you will, in the inner system, in the inner building, you will meet the king. And the king is secure to attackers. And this is the thinking behind it. And you also see it here in the picture. In the inner area, it's a component. Then you have the system, which is the machine, the network. Then you have policies and procedures, which is more what is allowed, what is the guard asking the people coming. And then you have some general areas. And the concept behind it is zero trust or zones of trust. In the beginning, zero trust means you do not trust any communication coming from the outside, for example. And zones of trust are the different layers. So inside the wall, but not inside the building of the king, and so on. And there are some methods how you can achieve this. The first logic method is security by design. So you design it in the product, in your machine. You think about security upon designing your machine. Security by default, which means by default, if you have a new product which is coming out of the box, the product is secure as possible. So there are no open ports, no let's say standard passwords, for example, and so on. So security by default. And then you need a secure configuration or hardening guide. So you need some documentation, and documentation is totally important in security and 62443. Secure configuration and hardening guide. So what should I do and what should I not do in the configuration of the product in the security thinking? You have to make some risk assessment. So you have to say, okay, my machine is inside a factory and the factory is not openly accessible. So nobody can come just inside the factory and plug in his PC in my system because there is some guards, there's some closed cabinets with a key. Not everybody can open the cabinet to connect to your machine, and so on. So risk assessment: what can happen? What what is the attacker's way to attack my machine? You need a secure development process. This is more focused on the product manufacturers like us, because if you do not have a secure development process, you will not define the requirements, test the requirements of security, and do all this stuff to get your product secure. Mostly you are focusing on functionality, for sure. The functionality has to be inside the product, but also the security has to be measured inside the product. And for this, you need a secure development system. And the secure development system, which is more focused on the IT side of the company, which helps you, or let's say, if your development system is not secure, some hacker can implement some backdoors into your firmware, because you do not see the people interfering with your development system. So you need a secure development system. And this is the most important point if you start implementing security in your company, and this was the first thing we did in Helmholtz 3 years ago. It's a security incident and patch management system. So it's totally important. You do not have a perfect product today in security, but you have to maintain your products. If somebody is telling you there is a vulnerability inside your Linux, inside your software you're using, inside your machine, inside your PLC, inside your panel, whatsoever, if you get this information from outside, from the press, from the manufacturer, you have to react. You have somehow to handle this. And I know for the machine builders, and especially for the end customers, it's not the, let's say, best thing to make the patch management, because you want that the machine is running. You want the machine producing money. And if you stop the machine every 2 weeks because there are some security patches, this is not funny. So you have to evaluate it, you have to plan it, you have to have a patch management, incident and patch management. Incident, something is happening, somebody is accessing to your panel and some firmware is changed and you do not know why. So you have to handle this. And this is really the first thing you should do in your company. And yeah, okay, then you need human resource handling and training. So the people working on the products, on the machine, on the network planning, on the end customer, everybody has to learn about what security means and what is allowed and what is not allowed, and where to take a closer look on some behavior of the machine. And this also incorporates the management. The management has to be willingly to implement all this, like an incident patch management, secure human resource handling, and so on. So these are some concepts, and you will find these concepts in the component for us, for like Helmholtz, for producing the products. You find the same concepts on the machine builder level, and also many of these topics as a concept for the end customer. So we will pick only one example out of the 62443 for machine builders, so the part 3. And there are many things like you have to have user management and roles management. If somebody is logging in, you have to have this patch management. You have many things in this standard. And one total interesting thing, and this can be implemented even on existing machines today, or on machines you will roll out in the next weeks, months, years, is the concept of zones and conduits. And this is written directly inside the normative, and this is a technology you can use. What's the background? You see here a typical, let's say, end customer factory. You have the enterprise level, the high level, where the boss is sitting or the planning guys are sitting, and then you have the industrial enterprise demilitarized zone, which is the factory itself with some data, MES system, data historian monitor, and so on. And then you have the machine. So industrial network 1 is one machine, industrial network 2 is a second machine, which possibly is delivered by machine builder, and they are all connected. We talked about this. They normally they are connected over Ethernet, over switches. And the normative states that you should have boundaries, zones, and conduits. The zone is like one zone of trust. Zone of trust is your machine. The next level zone of trust is the enterprise level, and the enterprise high-level network is the next zone. And between these zones, you need conduits. And these conduits, in a classical approach, coming from the IT guys, could be managed switches with virtual LANs. So this is possible and often used. But to have it more on a direct low-level product approach, you should implement on this level, like here in the pictures, something like a router, firewall, gateway, something directly as a product. And this can come from the machine builder. So the machine builder can bring as an entry point for his machine to the high-level network special hardware or software, also possible, but mostly it's a hardware, to have a conduit, a special conduit, to connect his machine to the high-level networks. So restrict communication between zones of trust. So this is a function of a conduit, and this can be a router, this can be a firewall, but this can also be a gateway and many other types of network controlling or network boundary devices. And yeah, we will start with a firewall as an example, as a conduit. We have a firewall called Wall.IE, and you see the practical example here. We have the company network, the factory network, and then we have the machine network. And this device is just plugged in between the networks. We have the upper level connector, which is connected to the high level network, and the 3 low level connectors here are connected to the machine network. And the device itself has the function to control the communication between the company network and the machine network. So everything which is coming from the company network is checked if it's allowed to be communicated to the machine network, but also in the other way, if the machine network is starting to communicate to the high level network or even to the cloud, it can be controlled. So access is only granted for listed devices and limit access in both directions. So it's not only the way from the top to the bottom, but also from the bottom to the top. And one really good feature which is helping the security here and helping also the machine builder to test the machine and then implement it in a factory, is that this device also doing a network address translation. So you see here the example. We have external IPs of the company network, which is here as an example 10.10.1 and something. And the machine was built up and tested with the IP addresses 192.168.10 something. So, and in the past, you had to change the IP address of your machine to somehow adapt to the company network. But nowadays, you take this product, you have this firewall functionality, but you also have this NAT functionality. So you can change the internal IPs to external IPs. And here's a good question coming up. How do I decide my zones, especially within the machine network? Yeah, zones depends on the areas of internal and external communication. So typically you have a machine, for example, which is communicating Profinet, which is communicating between the PLC and the panel and the motors and I/O. And this is some, let's say in the past it was the island, the communication island, like Profibus. And if you have this, you have a closed zone, and then you go one level higher to the next level. And this is, where do you have the different zones? This depends on the design and the structure of the network. So the question is, which components have to communicate with which components? And sometimes it's also a question about who is responsible for the machine, who is responsible for the high level network, and so on. So depends. I cannot answer this in a standard way, but you have to identify the zones of trust. The product also is able to has the functionality to implement packet filters for IP addresses, protocols, or ports. You can only limit the communication to a special port, just let's say HTTPS or the special port for accessing a Siemens PLC or whatsoever. And we also have MAC address black and white listing just to have the physical devices identified. So there are many functionalities inside this. And we have different types of this volley. There's the first version we had, the volley was 100 megabit, and the two ones on the middle and the right side are newer versions with gigabit, with only one interface for LAN or WAN, or up to 8 interfaces, which can be switched to LAN or WAN flexible. So this is one way to set up a firewall, so a conduit between high level and the machine network. The second possibility, and this is interesting just for the question we had a couple of seconds ago, you normally have the vertical communication. You have the machine on the bottom and the higher level of the network. But sometimes you also communicate in between different machines. And you can connect the machine networks, and then you have all this, okay, I have two PLCs inside the machine on the left side, on the right side. It gets really complicated. Or you have different island machines, and you use the high-level network to communicate from the machine one over the high-level network to the second machine. But this is also very complicated. You have to set up the firewall rules, virtual LAN and stuff like this. But there's a real easy way. If you want to communicate between two machines, you can connect them by a gateway or a coupler. And you know one device, I think, if you are in the Siemens world, the PNPN coupler. And this PNPN coupler is coupling two machines over Profinet. And the exchange of the data is only I/O data. There is no Ethernet communication running. The PNPN coupler receives I/O data over Profinet on one side, is copying this data to the other side and sending out by Profinet to the other PLC. So this is the best way to implement a firewall or a conduit. And it's a simple I/O data exchange between. There's no way to communicate in another way between the both machines or the both PLCs. And we also have a product range, gateway range. This is also a PNPN coupler, and you see the concept. You have one machine, you have the second machine, and you connect them on a horizontal way, not on the high level network. You go on the horizontal way directly between the machines, and this is very good firewall. No other Ethernet or TCP/IP traffics between the machine. And also machine performance is not influenced because there are no TCP/IP traffic running between the machines. And we have this for many different automation protocols. You can connect to Profinet machines, but you can also connect Profinet and Modbus TCP or Profinet Ethernet IP or even Profinet and MQTT. So you then have the communication to the high-level network. So you can also connect your Profinet machine to the cloud over MQTT without enabling direct TCP/IP communication between the machine and the cloud. So speaking of MQTT, there's also a big topic with MQTT. MQTT is used for data exchange between machines, for example, and high-level databases or cloud solutions. So MQTT is widely spoken in the cloud. And if you want to send, or if you have to send as a machine builder and the end customers urging you to do it, data to the cloud from your machine, you can do it directly over some firewalls from the end customer and connect to the cloud. But this is as secure as possible, but not the best way. And the best way, or we have one solution to solve this in a secure way. We have an MQTT broker, and you always need a broker somewhere in your system. And this broker is from the concept, it has two LAN interfaces. So you have the LAN interface on the left side, which is connected to the machine. And we have a LAN interface, a total different LAN interface on the right side, which is connected to the cloud somehow over the firewall of the end customer. And as the Profinet to Profinet gateway we had in the slide before, this one is only exchanging MQTT messages. So only the topic, the content of the MQTT value is copied from the one side to the other side and sent out by MQTT on the LAN interface X2, or vice versa. It's also in both directions possible. So there is no other communication possible, TCP/IP Ethernet communication between these two LAN interfaces. So this is also a firewall, and this is a firewall you can use from your machine to send data to the cloud. Yeah. And the last thing you can use, or you possibly already use in your machine, is remote maintenance or a router for remote maintenance. And yeah, the router is, let's say, on a security view, let's say the most, how can I say it in the best way? Risky is not the best to talk about the routers, because you need remote maintenance, but you need a trusted remote maintenance with VPN, with certificates, with security all built inside. And we have these routers called racks with they have all this security already built inside. And how does it work? You have your service engineer in the office or somewhere in the world, in the hotel, wherever he is, or at home. And he is connecting by VPN. So he has an encrypted and secure and, let's say, login security to our cloud solution, MyRex 24. And this cloud solution is connecting to the machine over the Rex router. And that's the point. If you establish a VPN connection to your machine for remote maintenance, the typical way is that the VPN enables you to do everything in the network, because the idea behind remote maintenance is that you are at home or in the company's office, but it is like you are in the machine with your laptop. You can work like you are in the machine with your laptop and plugging inside the switch. So this is what you sometimes need, because you have to access the whole network, access all devices. But normally, you do not need to access all the devices in the network. You need to access the PLC. You need to access the panel. And you have one guy for the PLC and the second service technician for the panel. And they are not allowed to access other devices in the machine's network, because they are not responsible for the other devices. And that's a point where you need, let's say, a more elaborated and a better firewall inside the router. And this is what we have. We can limit the access, the VPN access over our router to the user, and he is only allowed to access, for example, the PLC. If the maintenance guy is logging in and say, I want to talk with a machine in Brazil or in wherever, Asia, Taiwan, and he has established a connection, he is inside the network, but he is not allowed to access other devices than the PLC, because he is responsible for a PLC program and not for the panel. And this is also a really important point. You should use the functionality on limiting the access to the different devices in the router, in the remote maintenance. And this is also a conduit. The router includes a full-fledged firewall with rules, with technology, with user rights, and this is also at this point a conduit. Okay. Yeah, firewall not here. Okay. Okay, so round up my webinar here. You saw the zones and conduits is an important concept in the 62443. There are many more, but this is what you can do directly in planning your network and planning your usage of the devices of the remote maintenance. And I want to give you some more information how to handle security in the future as a machine builder or as an end customer. And the most important point is information is vital for secure OT. And information in this case is, where do I get information about security issues? So if I'm not looking for this information, I will not get informed. That possibly the companies are sending me emails, but who is receiving these emails about vulnerabilities in my company? Who is a responsible guy or the team which is responsible to react on security issues? So this is what I have to think about. Where do I get information about security issues of the machines or product I'm using inside my factory? Where do I get firmware updates? So if I have something I would like to have a new firmware, I would like to get the information about the firmware and so on. How can I secure my device configuration, or how do I do in the main focus a backup of my system? Do I have all the information? Because if I am attacked, the first thing what could happen is that somebody is changing the configuration, is deleting the configuration and so on. So do I have a backup or all the information about the configuration? So if somebody is attacking us, I can make a factory reset, put on the firmware, put on the configuration, everything, and the system running again, hopefully without the hacker inside. And yeah, who can I talk about security issues? So who is the people behind the machine in the factory or at the manufacturer? Who is the people I should talk to? And in the security legal parts like Cyber Resilience Act, like Machinery Directive, like 62443 standard, they always talk about you have to have a team or people or process to handle this. And it's called product, on the product level, Product Security Incidents Response Team, PSIRT. And Helmholtz already had this since 2 years. We have PSIRT team. And I'm a member of the CERT team, and developers and IT guys and product managers. And we have two different jobs. The first job is to get information about security issues which can affect our products. And on the other side, to receive information or to receive questions or communication with our customers, with external testers, and we have to be there to talk to the customers. And you can contact us by calling us, but you can also send an email to psirt@helmholtz.de. And we on our webpage, we have a long explanation about what is PSIRT, what we are doing, how do we handle vulnerabilities. And this is all the process behind this. This is all documented. And we need a partner for this because we are a smaller company in comparison to, let's say, Siemens, Phoenix, Vago, and name them. And we have a partner here in Germany. It's VDE CERT, and VDE is Verein Deutscher Elektrotechniker, so community of people doing electric business. And this is some people in this VDE, which they handle vulnerabilities, they handle security in Germany. They are also in the normative parties working on the legal parts and so on. And this is our communication partner. And the funny thing is, or the interesting thing is, in this community, all the big players of Germany, like Phoenix, Vago, Festo, Beckhoff, name them, bigger and smaller, are also together in this community to talk about security, to talk about vulnerabilities, to exchange, and we are all on one level on this topic. And we have other partners for informing us or talk about legal parts. It's Teletrust here in Germany, and also important BSI, Federal Office for Information Security. So we are also in contact with these both, or member of Teletrust, and have direct communication channel to BSI to get information about security issues, to learn about how to handle it, and so on. So this is really important for us. Okay, and this is all from now. Just as an end, what is actually doing? We not only have this PSIRT, we are just implementing 62443 development cycle. We will have a TÜV certification this year, and we are working on all our products to improve the security. And we will be prepared to have in all our products CE certification, security for all our products, latest December 2027. Okay, yeah, let's get secure. Together, we have to do something as a manufacturer. The machine builder have to do their part, and we can give them some information and some webinars or direct contact. And also the end customers have to do some more stuff beside the IT security. So we focus here on the OT security, and we all have to do this to get secure and yeah, to fulfill the legal parts, but also get secure, and our machines are on a higher level in security and better prepared for some attacks or something like this. Okay, thank you very much for joining us today, and we will send the slides after this webinar, and next week or later also the video will be online. You can take a closer look to the video if I talk too fast, possibly. And you can contact us directly by phone, by email. You can contact me directly. And if you have questions, if you want to exchange about some understanding of the normative or legal parts, yeah, thank you very much, and have a nice day, and see you. Bye.